Hello students, we are going to see that what is vector space. Vector space. Let F be a field a non-empty set capital V together with two binary operation called vector addition, that is internal composition, and scalar multiplication, that is external composition. Why we call it external composition? Because it is between the elements of V and R. Why we call plus internal composition? Because it is between the elements of V. Is called a vector space over the field F if following axioms are satisfied. The first, V is an additive abelian group. Additive abelian group means V plus with respect to plus binary operation. Then what is the abelian group, if you ask? Because not everybody is from pure mathematics background. So if engineering students are watching, then let's see that what is abelian group. Capital V is closed under addition. When we say that a closed word we use, that means when we put binary operation between two elements, and then the resultant should also contained in the set, then we say that closure property is being satisfied or V is closed under addition, that is U plus V belongs to capital V for all U V belongs to capital V. Means if we take two elements of capital V, then and we add them, then the resultant should also contain in the set V. Second property, this was closure property, and second property is associativity. What is associativity? We need three elements for all U, V and W belongs to capital V. This was the associativity. If you change the bracket, then the value doesn't change. Existence of additive identity. Existence of additive identity. That is U plus 0 equals to U for all U belongs to V. There exists 0 belongs to V for all U belongs to V. Next, existence of additive inverse additive inverse, that is, for all U belongs to V, there exists minus U belongs to capital V such that U plus minus U equal to 0. And minus U is called additive inverse of U. And fifth property that makes it abelian, the word abelian meaning commutativity. U plus V equal to V plus U. For all U, V belongs to capital V. That is, if the set with binary operation satisfies these four properties, then we say that V is an additive abelian group. This is first 5 property. Now, second major property is V is closed under scalar multiplication. That is, A U belongs to V for all A belongs to F and U belongs to capital V. आप एक एलिमेंट ले रहे हो स्केलर फील्ड का. You are taking an element of a scalar field F. You are taking another element of the vector field V, and you are multiplying them. Then you will get the resultant in V. Then we say that capital V is closed under scalar multiplication. So by this property, you can see that any vector space, any vector field will make vector space over the field F if and only if या तो F जो आपका सेट है वो V के इक्वल होना चाहिए या V से छोटा होना चाहिए. छोटा इन द सेंस V आपका C है तो F मतलब कॉम्प्लेक्स सेट ऑफ कॉम्प्लेक्स नंबर है तो F जो है वो अगर R होगा R set of real number, then it will satisfy this property. But if you take this as a Q, आप V को Q ले लो, Q means set of rational number, and you take F as a real number, then it won't make a vector space. Why it won't make vector space? Because if you take any element of rational number and if you multiply it with irrational number, then resultant will be irrational number. It won't be in the field Q, so it won't make a vector space. So to be vector space, the set V must be greater or equal to the set F. Third major property, scalar multiplication satisfies the distributive formula. The scalar multiplication satisfies the following properties. A U plus V equal to A U plus AV for all u v belongs to capital U, capital V, and this is U, okay, and A belongs to F. A plus B into U equal to AU plus BU. Again, U belongs to and AB belongs to F. What element belongs to which set? It is very important. We cannot ignore that. A, B, U. For all, AB belongs to capital F and U belongs to capital V. Fourth one is very important property. For all, U belongs to capital V, and one is multiplicative identity of F. So these are major properties of vector space, and if you get questions in exam that check the given example is example of vector space or not, then you need to check that all the properties of the vector space is being satisfied or not. If the given example satisfies all the properties, then you can say that it is vector space. So